Hello everyone, my name is Will Barden and today I will be talking about our work to develop the first Atlas Tier 3 compute cluster on cloud using Amazon Web Services. I've been working with Dr. Harinder Bawa and Professor Yongsheng Gao of California State University at Fresno. Now, the basic idea here is that if you're a data scientist or any scientist or researcher with a ton of data that you need to work on, you need a fairly powerful computer in order to crunch all those numbers. And those computers take up a lot of space. Here we can see a picture of a data cluster for CERN. You can see this takes up a lot of floor space. Some data centers take up entire floors or even entire wings of buildings to house all of the computer components and also the infrastructure like air conditioning, electricity, networking, all that fun stuff. This is incredibly expensive and is a fairly deep investment in order to maintain all of that hardware. And once you have the hardware, you have it. It's effectively a snapshot in time. If I buy a computer in 2003, that's going to be a computer from 2003 until I start replacing some parts. For data centers, that's a bit more work intensive. So the idea is that we can use cloud infrastructure, which is basically we get a data center or a series of data centers from someone else, like Amazon Web Services, and we use virtual machines as a compute cluster. And we can do everything virtually through them, and they're the ones that take on the burden of maintenance, dealing with real estate, electricity, all that fun stuff. We only need to basically rent the compute time from them. And there's a lot of savings to be had there. It's dynamically scalable, so at no point do we ever have more computer than we need. We don't have computers left lying idle, not working on anything. And at the same time, we don't have to worry about not having enough compute power either. If we need more compute power, we simply spin up more virtual machines. And when they're done, we simply discard them. They're no longer in use, they no longer exist, and we only pay for them while they exist. And this also means that it's a lot easier to upgrade. We simply move our setup from one virtual machine to the next seamlessly because everything exists virtually. We're not tied to any kind of physical hardware, which is really, really nifty. So enter Amazon Web Services. It's highly flexible. We are able to create virtual machines and networks on their infrastructure. A virtual machine is like a computer within a computer. Imagine that you're sitting at your desktop and you can open up a window and you're running Windows 10, but inside that window you have a full Windows XP installation because you have some little bit of software that only runs on Windows XP. Or you can run multiple virtual computers within your machine and have them all doing different things in parallel, operating side by side. And you can simply divvy up the hardware resources however you need them. That's kind of what we're doing here. We're able to network these machines together. We can even have one machine acting as a traffic cop or as a bastion to make sure that only the people that we want to be able to access our machines. And it's not facing the open internet and completely insecure. This is a very, very secure system because we're in complete control of how everything's networked and how everything talks to the wide open internet. And also deploying them is fairly trivial, as I'll get into on the next slide. Also, we don't have to worry about costs of for labor and for hardware, all that fun stuff. Everything's more or less a pay-as-you-go model. Amazon completely handles all the physical hardware and networking duties, so we don't have to worry about that. And we don't have to worry about upfront hardware investment. We don't need to spend hundreds of thousands of dollars on hardware today, especially when a lot of hardware isn't available. There's a global semiconductor shortage occurring at the moment. So if you wanted to build a compute cluster on-site, in-house, however you want to do it, it's going to be very difficult, if not impossible, to get your hands on a lot of hardware. Right now, global industry is kind of grinding to a halt because there simply aren't enough semiconductors, aren't enough computer chips to go around due to both COVID and due to climate crises, like what's happening in Taiwan with their water shortage, which is affecting the Taiwan Semiconductor Company, which is making it very difficult for them to produce much of anything. So EC2 is where I do most of my work. We're working with these EC2 instances. They can be instantiated relatively quickly. I can spin up a brand new EC2 instance in under 5 minutes, and when we automate that, it's even faster, which is really, really cool. They support most major operating systems, and most importantly, they support Linux. Linux is a free and open source family of operating systems. We use something called CentOS because that's what's preferred by most researchers, and these can be configured however we want. Generally, we use what's called a CLI, a command line interface, which is that kind of computer terminal thing where you just type commands and we're able to interact with the computer through just typed commands, and that's our best and most robust way of interacting with the computer. Now, the goal is to develop and to deploy a working Tier 3 compute cluster in a virtualized environment for use by the US Atlas Group and its members. we're replicating something called LX+. So if you've ever worked with CERN, CERN has something similar called LX+, where you can remote into it, you can have your data there, and you can use a CERN computer cluster to work on your data. However, that's hosted in Switzerland. There's a lot of lag between here and Switzerland, so I know from personal experience trying to work with that, the lag can be kind of painful to work with sometimes. And it's also just, you have to deal with networking issues. Dealing with stuff from the work computer that you're working on is half a world away. We've implemented CERN's virtual machine file system, which allows us to rapidly deploy software from something called Grid. So we can simply say, set up Atlas or set up root, and we'll pull the relevant pieces of software from CERN's Grid and deploy it into our virtual machine, no muss, no fuss, and everything's ready to go. But most importantly, it needs to be a viable alternative to each university or each Atlas Group member building their own compute cluster. And considering the way that things are going right now, that's looking to be more and more the case. It needs to be both cheaper and also needs to be easier to use. We don't want to make things more complicated for scientists who just want to get their work done and go through their data and make exciting new discoveries. So one of the things that we're working on is something called S3. S3 is what Amazon calls their storage system. The idea is that a user would submit a root job, we would look at the data set that they need, an external script would take as input the title of the data set, we pull that from storage, we let the script or work through it, we have the user, their program completely go through all the data, we simply then delete it when it's no longer needed, and we give the output to the research scientist who then goes on their merry way with their fancy new discoveries. And also on the right here we have a link to one of our websites where we have a little bit more information about our project. It's been a lot of fun. You can check that out if you like. My work has been basically getting a test environment working. So I was able to implement an EC2 instance based on CentOS. I was able to get CVMFS, the CERN virtual machine file system, and Grid working and implemented into our system image. I have the relevant commands working so that we can kind of replicate a lot of LX+ functionality. And we can execute something called root, which is used for statistical analysis. So if you have a very, very large data set, like what you would see coming from like a particle accelerator, where you have all these hundreds of thousands of particles and variables flying all over the place, that's a very large data set, you use a program like root to go through that data and see what sticks out and have fun with it. And we've also got the S3 bucket storage working for holding data sets, where S3 is basically just a giant bucket. It just holds all your data for you. We're able to monitor performance using Amazon's web interface. So here you can see, like, there's a bit of a diagram where you can see how we have our EC2 instances networked up top over here. And then below here you can see actual data input-output in the hundreds of megabytes. So we have 463 megabytes right here, 926 over here. And you can see how things are playing around right here. So, like, oh, this orange one is now disk write, the number of megabytes written to a disk. And through this we can actually monitor performance and make sure everything is working as it's supposed to. Right now our current plan is just to basically make sure that everything's working. We want to have things so that it becomes a bit more independent. We're using Amazon promotional credits at the moment, and our costs are fairly minimal. Our EC2 is on demand, and right now it's about $8 a day, a whopping $8 a day, compared to the millions and millions of dollars that you have to plunk down for physical hardware on site. We reserve instances ahead of time so that things are a little bit cheaper, so planning is important. But right now we're still in the testing stages on that, so we're not super duper worried about that. And we're going to be using 80 core simulation clusters. So imagine 80 separate computers all working together as part of a giant network to complete a single task or to complete a series of tasks, and network the together so as to be as efficient as possible. And I would like to thank everyone on our team. So there's Anand, Sagu, Eric Kaur, who are my fellow students at Fresno State, Dr. Bawa, Dr. Gao, Jay Fowler, John Wagenleitner, and Jeff King from our IT department at Fresno State. I'd like to thank Amazon's AWS team, which is Sanjay, Ami, and Varun, who have been more than helpful. Absolutely love those guys. And of course the US Atlas team for letting us pick their brains. So that's Kashik D, Fernando, Harold Barrero Magino, Johannes Elmsheiser, and Mario Lasnig. Thank you guys so much. And I hope this presentation has been fun, and now I believe we're going to do a Q&A.